All right, so today we're going to be talking about a few different properties of logarithms that are going to help us to be able to solve different logarithmic equations. So these properties actually remind me a lot about the properties we talked about with exponents. Now with the product property here, we'll have something like this, where we'll have log base 2 of 5 plus log base 2 of 6. So notice they have the same base here, so they're both that have that subscript of 2, equals, and now what we'd do is we'd keep that log base 2 and we'd multiply these two numbers together. All right, so this would become log base 2 of 30. All right, so another example would be something like this. We could have log base 4 of 3 plus log base 4 of 7. All right, and we would keep that log base 4 and again multiply these numbers together. So 3 times 7 would give us 21. All right, so this is again when things are being added together. Now this is called the product property, and that's because we can start with it like this. So if we were to reverse this example here, if we had log base 2 of 5 times 6, we could rewrite that as log base 2 of 5 plus log base 2 of 6. And you'll see where this property comes into play as we are working through a few examples. All right, the next one is the quotient property. So again, pretty similar to the exponent rules. So when we have a quotient, that means we're doing division, and in exponents, when we divide, we subtract the exponents. So it's the same idea here. So if we have something that looks like this, log base 5 of 3 minus log base 5 of 7, we could rewrite that as log base 5 of 3 over 7. All right, the same idea could be applied in the reverse. So if we had something that looked like this, log base 3 of 6 over 7, we could rewrite that as log base 3 of 6 minus log base 3 of 7. All right, so again, when we subtract and the logs are the same, we're going to put that into a fraction. All right, and then the last property we're going to talk about here is when we have a number outside or in front of our logarithm. So we can rewrite this as an exponent here. So see how we started with log base 2 of 6 to the 5th power. Well, this can be rewritten with this 5 out front of the log. So we can then have 5 log 2 of 6. So those are equivalent ways to write these. So let's say we had something like this. We could have log base 8 of x to the 6th. We could rewrite that as 6 log 8 of x. All right, or the other way around, we could write something that starts like 2 log 5 to the 5th equals, and then we could rewrite that as log base 5 to the 2nd power. All right, so again, backwards and forwards, two different ways to write this. Again, you'll see how this comes into play when we start solving these equations. All right, so let's take a look at this first equation that we're given. All right, now the first thing that I want to do is I want to take care of the right side of this equation. So I am seeing if I use those property rules that we were talking about before, where we had the addition, we can rewrite this as log base 7 of 27 times 3. All right, and that will give us log 7 of 81. All right, so then on here on the left side, I still have my 2 log base 7 of x. Now I'm going to rewrite this using the power rule that we just talked about. So I'm going to rewrite this as log 7 of x to the second power. Now again, what you'll notice, we've solved equations like this before. We have log base 7 on both sides. So what we can now do is just take this portion and set it equal to each other. So we now have x to the second equals 81. Now when we do that, we'll take the square root of both sides, and we get x equals plus or minus 9. Now remember, we have that plus or minus because x squared, if we take negative 9 squared, it would be 81. And if we take positive 9 squared, it will be 81. So we have that plus or minus sign there. All right, with the next example, we have another addition on that left-hand side. So I'm going to rewrite this first using that multiplication. So I have log base 6 of x times x plus 5 equals 2. So again, these are being added together, so I'm going to multiply these together. And that works because we have the same base there. So I now have log base 6 of x squared plus 5x. All right, so all I did here was distribute this x equals 2. All right, so now I'm going to get to a point where I need to rewrite this. What you'll notice is on the right side, we do not have any log 6 over there. It's just a 2. So I'm now going to rewrite this as 6 to the second power equals x squared plus 5x. All right, so this is using the same format we were working with before when we were rewriting from logarithmic to exponential form. All right, so we're just rewriting it here. All right, so I have 6 squared, so that's going to give us 36 equals x squared plus 5x. Now, I want to get everything over to one side. So I'm going to subtract that 36 over. So that'll leave me with x squared plus 5x minus 36 equals 0. And I just kind of swapped the sides that these were on. All right, so now we're solving. Remember, our goal is to get the value of x. So if I see an x squared and an x term and a number, I'm going to see if I can factor this first. And I can. So I'm looking for two numbers that add up to positive 5 and multiply to negative 36. All right, and that would be x plus 9 and x minus 4. All right, now when we are solving this, one thing that's important to remember is these factors are not our final answer. To solve to get the x values, we need to set them equal to 0 and then solve from there, just like we've done in previous units. All right, so I'm going to subtract the 9 over, so I have x equals 9, negative 9, and x equals 4. All right, so this process was a little bit different because we had to combine our left side of our equation first, and then we eventually had to rewrite it into exponential form because we had the 2 on the right side that didn't have that log there. All right, so now what you'll see is we have logarithms on every term here. Now, in doing this, I have a minus here. So that would automatically bring me to thinking, okay, I need to write a fraction. But since I have this logarithm on the other side, it's much easier to deal with multiplication than it is with division. It gets really messy. So what I'm going to do is, since I have log base 8 on this right side as well, is I'm going to add the thing that's being subtracted to both sides. So what that allows me to do, these cancel, I'm left with log 8 of x plus 10 equals log 8 of 12 plus log 8 of x minus 1. Now what that allows me to do is now I have a plus here. So I can now multiply these numbers together. So I have log base 8 of 12 times x minus 1. And then on the left side, I still have log base 8 of x plus 10. All right, so since, again, I have these logs on both sides, I'm going to kind of drop them. So I'm left with x plus 10 on the left. And then I'm going to distribute this 12 through, so I get 12x minus 12. And then I'm just going to solve from here. I'm going to subtract my x from both sides. So I have 10 equals 11x minus 12. I'm going to add 12 to both sides. So I have 22 equals 11x. Divide by 11. I get x equals 2. All right, so let's look at this next problem here and something a little bit different. So we want to try to get the log term all by itself. We want to move things over if we can. And this is just like how we solved the logarithmic equations before. So I'm going to start by adding my 6 over. So that leaves me with 3 log 5 of x squared plus 9 equals 6. Now I have this 3 out front that I want to divide by. It's attached to this whole term here. It's attached to this, so I'm going to divide by 3 to get that away. So it leaves me log base 5 of x squared plus 9 equals, and then 6 divided by 3 will give me the 2. All right, so here's another case where I am going to rewrite this in exponential form. So this base right here becomes my base. The answer over here becomes my exponent equals x squared plus 9. All right, so I have 5 squared is 25. All right, and then I have x squared plus 9. I'm going to subtract my 9 over, so I get 16 equals x squared. Take the square root of both sides. I get x equals plus or minus 4. All right, so the next couple pages are your homework that you will be doing. But I do want to highlight a few things on a couple of these problems that we didn't quite exactly get to full examples for. But I do want to remind you that if you have a situation like in number 1, where we have both of these logs on the left side and then we just have a number on the right, do what you can to clean up the left side and combine that first. So I'm going to combine this so I get log base 6 of, and I'm going to multiply those together. So 9x squared equals 2. All right, then I'm in a place where I can rewrite this into exponential form. You're going to be doing a lot of that on the homework here. So what that will bring me to is 6 to the second power equals 9x squared, and then you'll just solve from there. So you'd have 36 equals 9x squared. You'd divide, take the square root, and you'll be good. All right, number 3, we haven't directly talked about. So this one here, we did have one problem where we had a subtraction in it, and we added it to the other side because it's easier to work with the multiplication part, right? If we have the plus, we can multiply those numbers together. However, in this case, we don't have a log on the right side. So we're going to turn this into a division. We're going to bring that quotient rule back into play. So I'm going to rewrite this left side as log base 2 of 7 divided by 5 minus 2x equals 1. Now I'm going to take this and write this in exponential form. So I have 2 to the first power equals 7 divided by 5 minus 2x. And from here, I'm just going to solve. So I'm going to multiply both sides by 5 minus 2x. What that does will cancel there. So I'll now distribute. So 2 to the first power would just give me 2. So I'd have 10 minus 4x equals, then I'm left with 7 on the right side here. Subtract by 10 on both sides. So I'd have negative 4x equals, then I'd have negative 3. Divide both sides by negative 4. So x equals, I'm going to simplify this if I can, 3 over 4. All right, so this one was a little different. So the first thing we wanted to do here was put this into using the quotient rule, put this into a fraction. And that's because we did not have a logarithm on the right side, okay? So then we were able to turn this into exponential form. Now, if you look down at problem number 19, this is going to be similar to the one that we did in the practice, all right, when I was first showing you examples. So because we have a logarithm on the right side and we have this minus here, what we want to do is add that log base 2 of x over to the other side. And again, that just makes it easier to work with. So we have log base 2 of x plus 5 equals log base 2 of 53 plus log base 2 of x. And then we can just multiply those together to get log base 2 of 53x. And you can continue solving from there. All right, so just notice the difference. This one we do have a log on the right side. The other one we did not.